Now there is one more criteria for seeing whether a complex is going to be optically active or whether it's not going to be optically active. For that, let's draw a complex. I'll take cobalt as my central metal atom and I'm taking ethylene diamine as the ligand. Okay, don't worry, I'm going to draw ethylene diamine only. First, I'm just drawing all the nitrogen atoms. Okay, so now that we have drawn this, forget about it and let's come to some pens. This is a pen, right? Now imagine there is a mirror placed right here. Then this pen is going to have a mirror image and the mirror image of this pen is going to be this, right? So these pens are mirror images of each other. Now if you take the mirror image and put it over the original pen, you will be able to see that the mirror image is completely obscuring the original pen, right? Okay, let's just remove the pens now and come to hands. This is my hand. Imagine a mirror here. This is the mirror image of my hand. I take my mirror image of the hand and put it above my hand. Now is my original hand getting obscured by the mirror image? No, I can still see my original hand. Basically, you can still see my original hand, right? So when the mirror image, you can still see the original hand or original complex. Even if you put the mirror image on top of it, then that mirror image is said to be non-superimposable. And those two set of compounds or complexes are called non-superimposable mirror images. And the example of the pen I gave you, that was a superimposable mirror image. That is an example of superimposable mirror image. Now if a complex has a mirror image and it is non-superimposable, then that complex is going to be optically active. If a complex has a mirror image which is superimposable, that complex is going to be optically inactive. Let's draw the mirror image of this complex. So cobalt is in the middle, nitrogen here, then we have nitrogen, 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 nitrogen and nitrogen. So this is the mirror image. Now you will be able to see, if I take the mirror image and put it over the original complex, they will be non-superimposable. So this complex is optically active. And these two are mirror images, they are actually enantiomers. If one of them is dextrorotatory, the other one is going to be levorotatory. Let's say this one is dextrorotatory. Its mirror image is going to be levorotatory. And this is just guesswork I am doing right now. Whether a complex is going to be, whether an enantiomer is going to be dextrorotatory or whether it's going to be levorotatory is a completely experimental determination. You cannot determine it by looking at the structure and the orientation. It's completely an experimental determination. So this is another criteria for classifying whether a complex will be optically active or optically inactive. Personally, I prefer the plane of symmetry one, but you can do this also. Plane of symmetry one actually takes a lot lesser time. So, but again, it's according to you, whatever you prefer.